Alrighty, so now I want to take the opportunity to talk about our access list activity here and what it is that we're doing and why we are doing it. Specifically, why we're doing it is because most firewalls utilize what's called a 5-tuple configuration. I've heard it spelled or pronounced differently, tuple, tuple, whichever way works great for you. Basically, there's 5 objects or settings or configurations that are looked at for a packet by a firewall to determine whether packet should be allowed or denied. Those are source IP, source port, destination IP, destination port, and direction of travel. These 5 options, these 5 configurations are what's used by a firewall, by most all firewalls that are out there and exist today, to determine whether a packet should be allowed or not. Some firewalls go above and beyond this. For instance, Palo Alto will look at the application type and the user ID and other options as well. But these 5 are what's used by most firewalls, whether they be standalone firewalls like Cisco or Juniper, or firewalls that are built into your operating system, like in a Linux machine. So, for instance, if we had a source IP, we could say 10.0.0.0/24. Source port, we could say something greater than 1024. Destination IP 172.16.5.0/24, destination port of 80, and then direction of outbound. So what this does right here is this tells us that if we have traffic that comes from the 10.0.0.0/24 network, and comes from a port that is greater than 1024 and is destined for this network on port 80, which would normally be web traffic, that we should permit it, and then inbound or outbound based on the router's point of view. So these different tuples, these 5 tuples, are utilized to configure the various firewalling lists that most firewalls will utilize. So that's exactly what we want to do with this standard access list rule, with this access list activity. Now, one thing to note, this is in fact a standard access list. The standard access list is a simplified version of the 5 tuples. In fact, it is so simplified, the only thing it looks at is the source IP and the direction. It doesn't look at ports, it doesn't look at destinations. It only looks at the source IP and the direction of traffic. So with that being said, we have a couple of rules here to allow the management network to be able to access the server network, but to block the desktop network from accessing the server network. So the first thing we want to do is we want to write out what these rules would be. And again, since it's a standard access list, they're going to be fairly simplified. One thing to note, there is an implicit deny at the very end of all access lists and firewalls. So we don't necessarily have to deny a specific type of traffic. What we do is we permit the traffic we want to allow. So looking at the rules, we want to allow management traffic to the servers, but we want to deny desktop traffic to the servers. Since we have this implicit deny at the end, we don't need to worry about writing the deny for our desktop's network. We could simply write the permit for our management traffic. So we can go ahead and start filling out this spreadsheet here. We have our permit. And then the source, well, the source is going to be this network right here. and then which interface on the router do we put it, and for which direction. So we can look at our various router interfaces. We have an interface here, here, and here. Because we are permitting the management traffic and not the server traffic, that means it would have to be one of these two interfaces. But because we want it to interfere or work with both the management and desktop interfaces at the same time, or desktop traffics at the same time, then that means we would have to apply the rule right here on this interface. Now, I didn't put any interface descriptions or names here, so I'm going to go ahead and for the interface name, just go ahead and say server. And then as far as direction is concerned, it all depends on the router's point of view. If we are looking at traffic that is leaving the router, that is called out. If we are looking at traffic that is going into the router, well, that's called in. So if we look at what it is that we're trying to do, we are trying to allow the management traffic to go through, but we are trying to stop traffic from going through from the desktop network. So then if we're putting it on this interface here, then that means the direction is going to be out. So in theory, that is our access list right there. We're going to create an access list. We are going to permit 192.168.242.0 with a mask. We're then going to create an access group, on the interface, access group, and we are going to apply the access list in an outbound direction. So that should be everything that we need. The next step, down here, using Packet Tracer, build out the network, configure it, and make sure everything can ping to each other. So let's go ahead and open up Packet Tracer. And let's actually get the diagram there. So I'm going to start off with a router, 2911. In this case, I'm using a 2911 simply because when we look at the router itself, we'll see that it has right here 3 gigabit interfaces. That is the sole reason why I chose this router for this configuration. Otherwise, some switches, which we will not be configuring. We're simply using them for their switching capabilities. And then some PCs and a server. And then we use the copper connection to go ahead and connect these guys. And voila. Repeat that process for the other interfaces, and you will have your network configuration. All right. So once everything has been built out and IP'd, what we want to do is we want to ping and make sure everything is working perfectly. So I have here, I am pinging 172.16.14.10, which is the server IP address, with a ping-t, so it will continue pinging nonstop. Allows as a great troubleshooting step, so I can make changes, see if pings start or stop working. So that's from the desktop network. I'll set that to top so it never goes away. Do the same thing from the management network. Ping the same IP address. And not sure why that disappeared. There we go. So I can see now I have PC0, which is on my desktop network, and he is pinging successfully. I also have PC1, which is from my management network, and he is pinging successfully, and everything is working great. So now I want to go ahead and think of my rules that I am configuring, and go ahead and configure that here in my router. So I want to create an access list. In this case, I want to create a standard access list. I can go ahead and I can use a number here, or I can use a name. Numbers are useful if that's all you have. However, names are exceedingly useful if you have more than one access list, so you can easily find them and configure them. So I'm going to go ahead and create an access list. Just quick note, this is a standard access list I'm creating. Remember, the standards only look at the source, not the destination nor the port. So I'm going to go ahead and call this block desktops. So I'm currently in my access list here. If I hit question mark, I could see all of my various options that I have here. If we look back to what I had done previously on my spreadsheet, I want to create a permit statement, and then the default deny will, or the implicit deny at the end, will go ahead and deny my desktops. So I'm going to go ahead and permit, question mark again to show me more details. IP address 192.168.242.0 for my management network. Question mark again to get me more details. Wildcard bits. So if we think about this, the wildcard bits are the opposite of my subnet mask. So instead of 255.255.255.0, it is in fact 0.0.0.255. So 0.0.0.255, and then question mark, and I see I just have CR as an option here, which means carriage return, which means there's no additional options to include. So enter, and I have now created my access list. If I do, in fact, a show access lists, it now shows me my access list, block desktops, with my permit command. Everything else is denied. Looking very quickly at my configuration here, I could see gigabit 00 is on the 192.168.42 network, so that's my desktops. 01 is on the 192.168.242 network, so that's my management. And then 03 is on my 172.16, so that's server. So it is gigabit 02 on my configuration that I want to apply that access list. So go back into configuration mode, and in this case I'm going to configure gigabit 0/2. Here I'm going to do an access group, IP access group. It then asks me for the the access group number or name. So IP access group, deny desktops. Let me scroll up really quick, make sure that's exactly how I typed it. Any typo, case sensitive, makes a difference. Oh, it is in fact block desktops. There we go. Paste that in. And then the direction I want it to be, I think I said I wanted it to be outbound. And so now, as soon as I click OK, my desktops should stop pinging, should stop responding to my pings there. There we go. And there we go. We could see here my desktops are in fact now saying destination host is unreachable because I created an access list and then applied the access group to the interface in an outbound point of view. The PC1, however, is continuing on and working fine. So there you go. Once we are at this point, we can simply go back to our worksheet here and see, close that, see that we needed to document out what the access list would look like. In this case, it was only one line and everything was perfectly fine. We validated the configuration was working properly. We applied the access list and everything continued to work exactly the way we expected it to. So now what I need to do is just simply open up a Word document and paste in that access list that I had created up here. And then do a show run from the router and go ahead and paste that in and submit it. And that's all there is to it. And then as we move forward, we'll be having more and more of these, possibly reusing the same configurations, which is why I suggested to save it as it was.